Well, welcome back. I am working with number 48 that just wasn't going to fit on the other video or the most recent video. So 48A, B, and C are dealing with sine of 7 pi over 12, cosine of 7 pi over 12, and tangent of 7 pi over 12. Now, the point which is worth mentioning here is that we need to do two things. First of all, we were given 7 pi over 12 is the radian degree we want to work with. Now, we should also be aware of what quadrant that is in, and that is in quadrant 2, which means when I'm working with sine, it will be positive, and cosine, it will be negative, and I'll explain that further. But to use these half-angle identities, I first need to double the angle I've been given. And in this case, 7 pi over 12 doubled will reduce the denominator in half, or giving me 7 pi over 6. Now, why we do that is so it will look like the following right here. And we can cut it in half, which means we get back to 7 pi over 12. So I need this to look at, and this is by design. So now what happens to 7 pi over 6 over 2 as a half-angle identity is the following. We end up with a radical, now again it's this huge radical, of a 1 minus a cosine of 7 pi over 6. That is all over 2. Now, here we are dealing with sine, so I'm dealing with the positive trig identity. Remember or recall that we're always looking for a plus or minus depending on the quadrant in which the sine, cosine, or tangent lie in. So, again, we're in quadrant 2, so it's positive. Now, finishing up this problem, I really need to change my cosine 7 pi over 6 into a radical 3 over 2. Now 7 pi over 6 is going to get me in quadrant 3, which for the cosine will be negative. So negative negative gives me a positive. So that's why I have that 1 plus. Now, underneath it's a division of 2. So if I work out this problem by rationalizing, by getting a common denominator for the numerator, I end up with a 2 plus radical 2 over 2, and this is all over my denominator of 2. Now this is still that radical. So when I work this out, I get a radical 2 plus radical, this is radical 3, all over 4. Now this is a nice answer, however, we'll remember that we can split the numerator and denominator up, leaving me with a 1/2 radical 2 plus radical 3. Or I could have had a radical 2 plus radical 3 all over 2. Either one is a nice solution. Now if we move on to the cosine, we will again use our radical, and we're going to have a radical, but this time it's a 1 plus cosine of 7 pi over 6, all over 2. That's simply our formula. Now we're determining, do we need a positive or negative on the outside? Well, in quadrant 2, the cosine was negative, so I'm going to have my negative value out front. Now, again, probably a moot point doing these reductions, but I'll work through it with you. We have a 1 minus a radical 3 over 2, all over 2. Now, where did this negative come into play? Because cosine of 7 pi over 6 is definitely a radical 3 over 2, but it is negative. So, working this out, rationalizing the numerator, I have a 2 minus radical 3 all over 2, all over our 2 in denominator. And if we look at this, just for simplification's sake, we will have, and I'm sorry, I need to carry through my negative. I have a negative 2 minus radical 3 all over 2. Now remember, that will be gotten because these two will give me a 4 in the numerator or the denominator, and that will give me my 2. So just remember, this is a nice solution for us. We could, again, write it as -1/2 times the radical 2 minus radical 3. So there's our alternate. Now it's always nice to see tangent. Tangent doesn't have anything with the radical. For a change, the tangent might be the easiest process we have. So we're going to take the sine of 7 pi over 6 all over 1 plus the cosine of 7 pi over 6. Now, you might ask yourself, wait, what about the tangent? Don't I need to concern with where it's positive and negative? And in this case, no. By formula, it is always a positive value and works out due to the way it is designed or set up. Now, what do we get for sine of 7 pi over 6? We get a -1/2. And for our 1 plus cosine of 7 pi over 6, we get a negative radical 3 over 2. Once again, I would simplify. I'll do at least a step here. A common denominator giving me a 2 minus radical 3 all over 2. When I multiply by the reciprocal, then I really have the 2's canceling, giving me a -1 all over 2 minus radical 3. Rationalizing by a 2 plus a radical 3 all over 2 plus radical 3, I will eventually get to a -2 minus a radical 3. Now let's take a look at 49. Now 49, they're dealing with the same kind of problems, but they just sort of spell it out for us as sine u over 2, cosine u over 2, and tangent u over 2. And so what they give us is a sine u equals 5 over 13. And they tell us it is on this interval, pi over 2 and pi. And so that puts us from 90 to 180 degrees. Okay, 90 to 180 degrees. So it puts us in quadrant 2. So we're landing in this quadrant 2, which tells me I have a +5 and a radius, which is always positive, by the way, of 13. So right triangle trig, or using our Pythagorean theorem, we end up with a value of 12. So what does that mean? It means, what is cosine of u? Well, cosine of u is the adjacent over our hypotenuse. So we have 12 over 13. Now, should we figure out tangent u? The answer is no, because we don't ever use the tangent u. When we have tangent u over 2, we simply put it in a form where we have sine u and cosine u. So this is enough for us to work with. So here we go. Let us begin and see which ones we get done. So if I have a sine u of 2 that they want us to solve for, we'll put it into our formula, which is a 1 minus cosine u all over 2. Now again, I have a positive. I am dealing with quadrant 2, so it's positive value in front of my radical symbol. So what does that give me? It really gives me a 1 plus, because in this case my cosine u would be a negative 12/13. So I really have a 1 plus 13. So maybe it might be just best for me not to skip that step and just show or write it out for you. So it's a 1 minus and then a minus 13 or 12 over 13. And it's probably best if I show this negative up here, which I omitted because of direction. Remember, it's a distance, but it's in a negative direction. So this is what we have. Let me finish out this problem. If we work it out, we will see that we have 13 over 13, and we're going to add to it a 12 over 13 all over 2. This is under our radical. What does that give us? That gives us a 25. And so we have a 25 over 13 all over 2. Or in the end, I believe it gives us, let me make sure I'm doing this right. I'm seeing a 25 all over 26, and that is a radical. Let me do one quick. So this will give us a 5 over radical 26. You're getting pretty good at rationalization, which is 5 radical 26 over 26. So there is the solution for this one. If we go to B, I don't even know if I have that written down yet, so we'll go ahead and do that. We have the cosine of u over 2. Now this time it's a negative, and is it a negative? Let me think about this. Sorry for the interruption. Everything is good to go. So again, we are negative because we are in the cosine, and cosine is negative in our second quadrant. So what I have is this big long form again, a 1 plus this time cosine u all over 2. Now if I solve this and substitute in, this time I will have a 1 minus 12 over 13 all over 2, which gives me then a LCD in the numerator of 13 over 13 minus 12 over 13 all over 2, which yields the 1 over 26 as our radical. Simplification tells us we have a 1 over radical 26 or radical 26 over 26. And last but not least, we'll jump into a beautiful problem of dealing with tangent. Now remember, the tangent to, u divided by 2, or the half angle, I said we would not have to worry about coming up with the tangent u. And again, the reason is because this is set up as sine of u all over 1 plus cosine u. Now we substitute in, we have a 5 over 13 all over 1 over a negative 12 thirteenths. Simplifying, 5 over 13 all over, and in this case we're going to end up with a 1 over 13 multiplied by the reciprocal yields the answer of 5. So I hope these were helpful, and you have a great day.